Hi there, welcome to my channel Tech Recaps. Today, I'm going to give a brief recap of the newest technology. The new type battery made from sea salt has 4x capacity of lithium battery. A team of talented researchers at the respected university in Sydney has been hard at work on a revolutionary new technology. Meet the new sea salt sodium sulfur battery, the latest breakthrough in energy storage. These cutting-edge batteries are poised to shake up the industry and change how we think about power. Imagine a world where renewable energy sources like solar and wind can be stored efficiently and cost-effectively. That's the promise of the sodium-sulfur battery. With a long lifespan and the ability to store a large amount of energy in a small space, they're ideal for storing energy from renewable sources, which can be intermittent and difficult to predict. But the benefits of this sodium-sulfur battery don't stop there. They're also extremely safe, with no risk of explosion or fire, and they're environmentally friendly, made from abundant and easily obtained materials. Are thought to be among the most cutting-edge sorts of technology available today. Lithium-ion batteries, which are among the most extensively used rechargeable batteries, are distinguished from other rechargeable batteries by their high energy density and lengthy discharge rate. Because of their high energy density, they can store more power than normal ones, and their lengthy discharge rate prolong the time they can be charged. Lithium-ion batteries are commonplace. They power everything from laptop computers and cell phones to electric cars. They are frequently used in the military and aerospace and trees. So why is the tech industry so divided in replacing lithium-ion batteries, despite all of the benefits? Lithium-ion batteries have drawbacks as compared to other rechargeable technologies. Lithium-ion cells and batteries have a short lifespan since they must adhere to current standards in order to remain within safe limitations. One disadvantage is that they require protection circuitry to keep them within safe working limits. Lithium-ion batteries degrade over age, which is a key disadvantage in consumer products. This relies not only on its age but also on the number of times it has been charged and drained when not in use. The reduction in capability is caused not only by consumption but also by the passage of time. When a regular consumer lithium-ion battery or cell needs to be stored, it should be kept in a cold storage place and only partially charged between 40 and 50%. While storing it, it will extend its useful life. Most batteries have a lifespan of about 3,000 charge cycles before they lose capacity. More and more devices are becoming lithium-ion powered, but replacing the batteries in these devices can be a problem if they are permanently built into the apparatus. However, there may be a shortage of batteries. Protective coverings etc. must be used on any lithium-ion batteries carried separately. To prevent short circuits, it's especially important if it's a lithium-ion battery. Another significant disadvantage is the high cost of lithium-ion batteries. They are typically much more expensive to produce than sea salt batteries in the context of mass-produced consumer goods, where even minor price increases can have a significant impact. This is an important consideration to avoid damage. Because all of the lithium ions have been taken from one of the electro-highways, lithium-ion cells should not be depleted or fully charged because the electrode degrades rapidly in either state. The most pronounced disadvantage of the lithium-ion battery is the supply strain of lithium. Lithium is one of the most abundant elements found on Earth, and it is in high demand because of its use in the production of batteries primarily for electric vehicles. But soon there may be a shortage of lithium supply around the world. The cost of lithium carbonate, the substance mined from the Earth, has increased by a factor of 432% year-over-year, reaching approximately $62,000 per metric ton in 2022 comparatively during the preceding 6 years. The annual average was close to $11,000. The price increase can be attributed to the rapidly expanding market for electric vehicles, which is putting demand pressure on battery manufacturers, who in turn are putting demand pressure on mineral suppliers. While lithium is abundant on Earth, it must be mined from brine pools and underground sources to meet rising demand from the automotive sector. Unfortunately, the mining operations that are currently in place are insufficient to meet this need. Brine reserves, according to a study conducted in 2019, pegmatite deposits and sedimentary rock deposits are the three distinct types of lithium deposits. Hard rock mines take 3 to 5 years to become operational globally, while brine projects might take up to 7 years. According to industry professionals such as Casper Rolls, chief data officer at Benchmark Mineral Intelligence, the time it takes from the discovery of a mineral deposit to the beginning of production is 7 years. It is more than twice as long as it takes to develop other supply chain components such as battery factories. This suggests that the lithium supply issue has been looming for some years, implying that the market should be wide open for newcomers like saltwater batteries to secure a piece of the pie right now, which is why saltwater batteries feature highly concentrated saline or salt water solutions that are utilized to store electrical energy. This electricity will be used subsequently to power electrical equipment that require electricity to operate. Saline water includes sodium ions, which are found in table salt. These ions carry and store electricity in the battery. Saltwater batteries provide numerous advantages. The fact that saltwater batteries are fully risk-free is without a doubt their greatest advantage. This type of battery is run utilizing a highly concentrated mix of salt and water. As a result, unlike traditional batteries, they do not pose the same risk of accidental fires, and they do not contain any potentially hazardous compounds. This means that saltwater batteries are safe for the environment, people, and other types of flora and fauna, and that they have a longer lifespan despite having a very simple design. Construction saltwater batteries are extremely durable and long-lasting. A normal saltwater battery may withstand nearly 5,000 charge and discharge cycles. However, they are easily usable. This minimizes the frequency with which you'll need to replace the batteries and, on top of that, it requires no ongoing maintenance beyond this cycle. One of the most major advantages of employing these types of barriers is that saltwater batteries do not require frequent maintenance. When utilizing them, you can receive a complete discharge of the stored electricity without depleting or harming the battery. As a result, the battery will not be harmed. See a loss in its life cycle or efficiency, and a single charge can keep it powered for several weeks. Aside from the occasional requirement for charging, they do not necessitate any major maintenance, and storage does not necessitate any specific measures. As a result of using concentrated sodium salt solution as the cell component of saltwater batteries, there is no risk to the surrounding ecology, and it is also harmless to all living creatures and has no negative influence. Despite representing a massive technological leap, saltwater batteries are not without their drawbacks, and it is simple to recycle. Saltwater batteries can also be reused. Only very concentrated sodium salt water solution is contained within these batteries. As a result, they do not contain any potentially hazardous chemicals that could harm humans. This means that the process of recycling the individual parts and components of the batteries can be reused repeatedly in the manufacturing of new batteries. But as we say, there is no such thing as a silver bullet to solve the issues with the battery industry, as each iteration of the battery comes with its pros and cons, and just like any battery, the salt battery tool has some cons to the amount of current or capacity that a battery charges with and then discharges later is referred to as the C rate of the battery. Ought to be as high as feasible. Unfortunately, saltwater batteries do not fare well in this area. The only C rate they come with is 0.5, which is an extremely low value. This means that a single charge will only allow these batteries to discharge 50% of their total electrical reserve, which is why saltwater batteries are insufficient to supply significant electricity for a shorter period. They have a low capacity for storing charge, so they can only hold a limited amount of energy to put it. If you compare one saltwater battery to a lithium-ion battery of the same size, the lithium-ion battery will be able to store more electricity than the saltwater battery because of the lower energy density. Larger-sized batteries are typically required, which may be an issue if limited space is available. As a result, saltwater batteries may not be the best option in some circumstances for the technology market. Compared to lithium-ion batteries, saltwater batteries may pose significant competition to lithium-ion batteries with these new modifications. Researchers from the University of Sydney claim that their newly developed battery, which has a low price point, will make the transition to a decarbonized economy cheaper. The battery was created using sodium sulfur, which is a molten salt that can be produced from seawater. Dr. Shenlong Zhao of the University School of Chemical and Biomolecular Engineering oversaw the battery's research. Although sodium-sulfur batteries have been around for almost a half-century, their widespread application has been severely limited due to their low energy capacity and short life cycles. Using a simple pyrolysis technique and carbon-based electrodes to boost the reactivity of sulfur and the reversibility of interactions between sulfur and sodium, the researchers built a battery with an incredibly high capacity and an unusually long life at room temperature. The sodium-sulfur battery, according to the researchers, is a less damaging and more energy-dense alternative to lithium-ion batteries. Lithium-ion batteries are also more expensive to manufacture and recycle. Dr. Zhao's sodium-sulfur battery has been purposely designed to provide a cost-effective and high-performing option for storing massive amounts of renewable energy in systems such as electricity grids while substantially cutting prices. Dr. Zhao said of the sea salt batteries, "Our sodium battery has the potential to drastically lower prices while greater are chances of limiting global warming. Storage solutions made from abundant resources, such as sodium, which can be processed from seawater, can also ensure greater energy security more broadly and allow more countries to join the shift toward decarbonization." The team at Sydney University has been tirelessly working on perfecting this technology, and their efforts are paying off. These batteries are now ready for the real world, and the possibilities are limitless, from powering homes and businesses to providing support services. Expansion of renewable energy. The sodium-sulfur battery is destined to change the game, so think of the brilliant minds striving to make our energy future brighter and cleaner the next time you flip a light switch or charge your phone. The sodium-sulfur battery is here, and the future is looking bright. Continue watching my video as we will continue to explore more on newest technology today. Don't forget to subscribe, like, comment, and share.